In this video, we will be discussing the qualities of populations, how they grow, decline, and different types of interaction. So let's get started. The definition of a population is all the individuals of a species that live together in an area. If you recall from the beginning of the ecology unit, we discussed the hierarchy of the ecological levels. Population is second to most specific ecological level, where there are multiple organisms of the same species interacting together in the same environment. Not all populations are the same. Some are large, some are small, some are stable, and some grow uncontrollably. We will look further into the differences between different populations. There are three properties that all populations have in common. That's size, density, and dispersion. So let's start with size. The size of the population is the number of individuals in a particular area of the same species. Populations have size in geographical boundaries such as mountains, rivers, and oceans. Next is density. Density is different than size because size is the total number of population. Density is the number of individuals per unit of area. Urban areas have more density than areas like the country or rural areas where they have less density. Urban areas have more individuals in a smaller area, whereas individuals in a rural or country area are more spread out. Dispersion is a quality that explains how individuals arrange themselves within the population. The three types of dispersion are uniform, clumped, and random. The clumped dispersion is when individuals of a population stay close together, but the clumps may be spread out. Protection is the major reason why clumping occurs. Using a school of fish here as an example, they are more protected from predators when they travel together versus swimming alone. Also, when resources such as food and living space are clumped, this causes the individuals to clump as well. Uniform dispersion results from social behavior, such as when animals within the same habitat stay as far away from each other as possible. For example, a bird may locate its nest in a way where it is farther from other birds' nests for privacy. Random dispersion is the least common. Most show degrees of clumping and uniformity. When random dispersion occurs, it may be because the environment lacks resources and individuals flock to wherever they can find them in a random distribution. Demography is the study of statistics that affect a population size. Statistics such as birth rates, death rates, immigration, and emigration are all factors that affect population size. We all know what birth and death mean, but immigration and emigration may not be so familiar. Immigration is when the individuals move into a population, and emigration is when individuals move out. A higher birth rate and immigration will cause populations to grow. A higher death and emigration rate will cause populations to sink. If we look here at Figure 1, birth and immigration have a blue line which represents growth. Death and immigration have an orange line which represent a decline. If all four balance between each other, that would represent a stable population. The dynamics that affect population size are size, density, dispersal, immigration, emigration, births, deaths, and survivorship. The only term we have yet to discuss is survivorship, which is the length of the lifespan per individual. So how do populations grow? There are two types of population growth, exponential and logistic. Exponential growth is uncontrollable growth. The individuals are growing at a rate that exceeds the resources that can sustain the population. After a population reaches a point where the resources are gone, the population will rapidly decline. Unfortunately, this is the population curve for the human population, which is why we need to be smarter with how we use the resources we have left, because once they're used up, the human population will rapidly decline. Logistic growth is a more controllable growth. The population grows until it reaches a point where the maximum amount of individuals meets the maximum amount of resources that can sustain a population. We call this the carrying capacity. The population levels out and becomes stable around the carrying capacity line. As you can see here, we have the exponential graph. At the bottom, there's little growth over a large period of time. Then it starts to pick up and grow rapidly while using a lot of resources. If this graph were to continue, it would exceed the carrying capacity of the environment and rapidly decline. Oops, sorry guys. Here's a closer look at the logistic graph. In the beginning again, we have a slow rate of growth over here, but then it starts to pick up, and then the population reaches the carrying capacity where it hovers around that line and should stay stable unless some disturbance within the ecosystem happens and disrupts the population growth in some way. All resources, for the most part, are not unlimited. There is always a limit to resources in an ecosystem and a time frame for how long they can regenerate. Therefore, because resources are limited, population is limited by the amount of resources. This is why growth in a logistic curve stabilizes by the carrying capacity line. There are two types of limiting factors that affect population growth in a decreasing manner. First, we have density-dependent factors, which are biotic or living factors that decrease in a population. Things like disease, the amount of resources in the area, and predation are all types of limiting factors that are called density-dependent factors. The second type of limiting factor that decreases populations are called density independent. These are going to be the abiotic or the non-living factors such as tornadoes, hurricanes, floods, or any other natural disaster that may impact a population in a negative manner. The human population has been growing almost exponentially for 3 centuries, but cannot do so indefinitely. We've doubled 3 times in the last 3 centuries, and about 7.2 billion people currently live on Earth. Because of improved health technology, our death rate has decreased, and our birth rate continues to increase. This is what causes the exponential growth. There will be so many more resources like fossil fuels, food, and room for shelter until the population will exceed the resources. Unfortunately, when that happens, the human population will decrease just as fast as it is growing. The only way to slow down this process is to find alternative sources, be frugal with the resources that we have, and to also limit the amount of births that we allow into the population. But ethically, how do you tell a family that you can only have 1 child? You really can't. So this is where the problem lies, and this is why the problem has yet to be solved. There is one type of model that shows the population breakdown of a particular area by age and sex. These are called age structure diagrams. So let's take a look at what they look like. So here we have 3 models of age structure diagrams. The first one over here shows an increasing population because the younger ages have a higher population. The middle model right here shows a steady population because there's not a large difference between the youngest, the middle, and the older ages in terms of population amount. And the last model over here is going to show a decreasing population because we have the smallest amount for the youngest age group right here because they are the least amount in the entire graph, and we do show a larger amount in the middle of the graph. Therefore, that shows a decreasing population.